Okay, this problem is 3 parts, but it's not that complicated. It's like the free fall stuff we were doing in class, right? It's just the first one involves 2 steps. So there's 2 parts to this problem. It says a tennis ball's dropped and then it rebounds to a different height. So mine is dropped from 1.2 meters. So here's my tennis ball. And I drop it and it gets faster and faster and then it hits the ground, right? Here's the ground. And this height here is 1.2 meters. That's my delta y. And then it says it's going to rebound to a height of 1 meter. So after it bounces, it hits the ground and it shoots back up and it does this. And it goes to here. And when it goes back up, the delta y is 1 meter, right? And so this is 2 separate things, right? Remember we talked about free fall stuff. We can treat anything in the air treat it like only looking at half of it, right? So this is just the opposite of throwing something up and letting it come down, right? This is dropping something, letting it bounce and come back. It's still going to behave the same way, right? I can look at just the before and just the after. So let's only look at the before, because the first question says, what's the velocity? With what velocity does it hit the ground, right? So let's see what I know. I know 1.2 is delta y. I know that for both of these, the acceleration is 9.8 meters per second squared, right? Because both of these things are accelerating down because of gravity. So I know delta y. I know my initial velocity is 0, right? That's the point of looking at half of it, because I know at the high point it's not moving. So I know my initial velocity 0. I know my acceleration is 9.8. And I want final velocity, right? So I know distance. Do I have an equation that has height, initial velocity, acceleration, not final velocity, and I don't have time, right? I don't know VF or time. I don't have one of those, right? Every equation has either distance or time. The one equation that doesn't have time has distance. So I can't just off the bat solve something. But if you remember, when we talked about free fall stuff, there's 2 equations for things in free fall. So free fall things, I can say the height fallen is 1/2 times the acceleration times time squared, where the acceleration is 9.8. And I can solve for time and say the time is the square root of 2 times the height over the acceleration, which is 9.8. Right? So here, I can get time. All I need to know to get time is the height. Right? So let's do that first. So first, we're going to find the time. So I'm going to do, my time is the square root of 2 times my height, which is 1.2, divided by, I should have put 1.2. 1.2. Just pretend I wrote it right. Over 9.8, square root of that. So I'm going to do 2 times my 1.2 divided by 9.8. That's going to give me a time. Now that I know time, right, I don't need that. Now that I know time, I can plug time in here. And then I can use final velocity equals initial velocity plus acceleration times time, right? It's a matter of looking at what stuff you know and what equation works, right? So now that I know time, I mean, technically, well, no, you couldn't have used the other one because you're trying to find final velocity. But the only equation that would work is this one with what you have, right? Again, it's a matter of writing out the stuff you know and then picking an equation, right? So first I had to get something I didn't know. And now I look at my stuff and I say, oh, look, I can solve this, right? You don't even have to do algebra. You can just solve for final velocity, right? And that's the final velocity right here before it hits the ground. Okay. Then second question says, with what velocity does it leave the ground? So this is different. This one, it's going to bounce back up, right? So to do this one, I have to look at the acceleration. I have to figure out how fast it took off back upwards, right? So I'm going to look at this half of the equation, right? So here, my initial velocity is going to be at the ground, which I don't know. But I can say my final velocity is 0, right? So I'm looking at this half of it now. I know my final will be 0. I know my height is delta y. I know my acceleration is 9.8. So let's go through what I have. I know v0 is 0. I know my height is 1. I know my final velocity. Oh no, I don't know v0. That's a question mark. My final velocity is 0. This should be a question mark. And do I know anything else? I know the acceleration had to be 9.8, right? Because everything in the air is 9.8. So what equation has all of this stuff that I could get initial velocity? And if you look at it, right, if you look at your three equations, you should be able to pick which one. Should be this one. VF squared equals V naught squared plus 2A delta, well, in this case it's Y, right, because we're talking about up and down. So if I take this equation and I solve for initial velocity, I should get that, right? So solve for initial velocity, I can subtract all of this to the other side. So V naught squared, my pen is dying, equals final velocity squared minus 2A delta Y. And you can plug in your numbers and you can solve that, right? And so again, to get rid of the square, I have to square root. So really you're solving that, right? My final's 0, A is 9.8, my height is the second part of the height, and easy, right? Something I forgot to point out. Here it says let down be negative. So my answer from part 1 should be negative because it says let down be negative. It's calling down negative and it's calling up positive. So this answer should be positive. This answer should be negative, right? And then the third question says, if the tennis ball was in contact with the ground, find the acceleration of the tennis ball by the ground. So now we're not looking at the falling down. We're not looking at the going up. We're actually looking at, here's the tennis ball before it hit the ground, and then it squishes, and then it's going to bounce back and shoot back upwards, right? We're looking at this acceleration. We don't know that acceleration. That's not 9.8. That's the ground pushing back on this thing upwards. But it's not a complicated problem to solve because the definition of acceleration is change in velocity over time, right? And remember, just like we did velocity, that's final velocity minus initial velocity over time interval. So do I know these things? Well, yeah, because you just solved them, right? Here's my time. That's delta t minus 0.01 seconds, right? So I would put 0.01 in here. My final velocity is going to be here. That's my answer from part 2, right? That's what I figured out in part 2. I figured out how fast it took off from the ground, right? So that's my final velocity. And my initial velocity is going to be right here. That's what I answered in part 1. That's how fast it hit the ground, right? So this is your answer from part 1. And so if you plug in your answer from part 1 and your answer from part 2 for your final and your initial velocities and you put in your time, you should get an acceleration. And when you think about this acceleration, the number you get should be positive because the ground is pushing upwards on the ball, right? So this, if you can do this where you pick out the variables that are what, this was a little more complicated of a problem, but still it just requires that you be able to tell what's what and you be able to pick the right equation, right? And then because it's free fall, some of the stuff you just have to know, like, oh, this thing's falling, it's 9.8. Oh, the velocity at the top has to be 0, right? Whether it's final or initial is something you have to think about.